told you that the deadliest part of a modern military explosive isn't the shockwave or even the
Yeah.
shrapnel.
Right. It's not the crater left behind either.
Exactly. What if the most dangerous part of a detonation is entirely invisible, survives the initial blast, and just, waits patiently in the dirt for decades?
And eventually ends up on your dinner plate.
Yeah,
It completely changes how we calculate the collateral damage of human conflict, doesn't it?
it really does. Welcome to today's deep dive. Today, we're looking at a 2023 review article from the journal Discover Sustainability. It's titled Ecotoxicology of Magnesium-Based Explosive, Impact on Animal and Human Food Chain.
It's a fascinating paper.
Yeah.
Yeah.
And our mission today is to basically pull back the curtain on this massive blind spot.
Yeah.
We're going to track a single particle of weaponized metal from the inside of a warhead through the environment, up the food chain, and directly into our bodies.
And the specific metal we're tracking here is magnesium. You can really look at this review as a massive early warning system. Modern explosives don't just, vaporize targets.
Right.
They release these incredibly dense clouds of metallic residue. And because these detonations are happening globally, constantly, we're dealing with widespread systemic contamination of ecosystems.
Okay, let's unpack this right out of the gate because there's a glaring paradox here, right? Like, my daily multivitamin has 250 milligrams of magnesium in it.
Oh, sure. It's an essential nutrient.
Right, my body needs it to survive. So how does a bomb blast take a crucial biological building block and just, turn it into an environmental poison?
To understand that, we kind of have to look inside a modern warhead. Because today, militaries and civilian engineers, they don't just pack steel tubes with old-school gunpowder anymore.
Right, it's way more advanced than that.
Exactly. They use what are called plastic bonded explosives, or PBX.
PBX, okay. So they're mixing raw explosives with, industrial plastics.
Yeah, think of it like a highly lethal composite material.
Yeah.
You have these energetic crystals, the volatile compounds that actually explode, suspended inside a synthetic rubber binder.
Oh, interesting.
Yeah, a common one is a polybutadiene compound. The rubber matrix makes the explosive super stable to handle. Like you can drop it, shake it, and it won't accidentally detonate.
But then when they actually want it to detonate...
Right, to maximize the destruction, weapon designers mix raw metals directly into that rubber.
Okay, so I imagine they use dense metals, right? Like tungsten or steel for shrapnel.
They do use those, yeah.
Yeah.
But magnesium is the secret ingredient for sheer thermal violence.
Thermal violence. That's a phrase.
It's accurate, though. Magnesium reacts furiously with strong oxidants. When you pack pure magnesium powder into a PBX formulation, it acts as a chemical turbocharger.
So it just amps everything up.
Massively. It burns incredibly fast and just unfathomably hot. It boosts the combustion efficiency, the blast pressure, and the blinding heat of the explosion.
It's like pouring liquid oxygen onto a campfire. You're taking an already destructive baseline and pushing the thermal physics to the absolute limit.
That's a great way to put it.
But here's where I get stuck. Magnesium is, the 8th most abundant element on Earth. It's in the ocean. It's in the rocks in my backyard. Why is this specific weaponized magnesium dangerous if the stuff naturally sitting in the dirt is totally harmless?
Well, the danger comes from its physical state and how violently it's introduced to the environment. In nature, magnesium is locked away inside rocks, right, like dolomite or serpentine.
Okay.
It's highly stable. Rain and wind might slowly weather a microscopic amount over 1,000 years, which just feeds the soil at a slow drip-feed pace.
Right, a pace the ecosystem is perfectly evolved to handle, like a geological time-release schedule.
Exactly.
Yeah.
When you detonate a PBX, or fire large-scale propellants, you subject that powdered magnesium to thousands of degrees of heat in a fraction of a microsecond.
Wow.
The metal is completely vaporized. It bypasses that 1,000-year cycle instantly. And the explosion generates this massive rolling cloud of highly concentrated ultra-reactive magnesium fumes and explosive dust.
Which just settles directly onto the topsoil.
And the water surfaces, yeah.
Yeah.
In a form and at a volume, that local biology is absolutely not equipped to handle all at once.
So this reactive dust is now just drifting in the wind, completely unfiltered. And what makes this terrifying is the sheer volume of where this is happening.
Oh, yeah.
We naturally think of active war zones, right? The paper highlights heavy explosive use in places like Syria, Afghanistan, Iraq, Libya, and obviously the ongoing artillery barrages in Ukraine. But this toxic dust is settling in places experiencing total peacetime too.
Yeah, we connect this to the bigger picture. The global footprint is staggering. Militaries require constant readiness, which means constant large-scale practice.
Right, drills and stuff.
Exactly. Massive live fire training grounds and testing facilities in the US, the UK, Russia, India, China. Every single branch of the military runs daily drills using these exact magnesium-laced compounds.
Plus the entire civilian side of the equation, like mining operations, blowing the tops off mountains, or civil engineering projects punching highway tunnels through bedrock.
Yes, they rely on vast quantities of these high-energy, metal-heavy formulations. And, gravity always wins. Millions of tons of these microscopic reactive particles get launched into the atmosphere, and they eventually have to come down.
And I'm guessing they don't just wash away in the rain?
No, they don't.
Yeah.
Because these magnesium compounds attach very easily to organic material. So over decades of repeated detonations at a testing range or a mining site, the metal residue relentlessly builds up, layer upon layer in the ecosystem.
So this toxic dust is raining down globally. When those millions of tons of reactive particles finally hit the Earth, how does the dirt actually react? Because the chemical balance of the ground has to snap under that kind of pressure.
It really does. The contamination pathways are swift and brutal. The dust physically coats the leaves of the vegetation and blankets the topsoil. And then when it rains, surface runoff sweeps those suspended particles directly into lakes, rivers, underground aquifers.
Just a direct pipeline to the water supply.
Right. And to give you a baseline, the maximum permissible level of magnesium in drinking water is around 20 milligrams per liter.
Okay. But what about the dirt itself? Because if I go to a local gardening center, I can buy a bag of magnesium to sprinkle on my tomato plants to help them grow.
Sure. In a healthy, balanced environment, soil magnesium levels generally hover between 3 and 25 grams per kilogram. It feeds the plants.
Right.
But test the soil in these blast zones, and the concentration can spike well past 40 grams per kilogram.
Oh, wow.
At that density, it crosses this invisible threshold from a vital nutrient to just an aggressive environmental poison.
I really want to dig into how that poisoning actually works biologically, because intuitively, you'd think a plant would just, absorb the magnesium it needs for the day and ignore the rest of it. How does a massive surplus of a nutrient actually kill a plant?
It comes down to a microscopic turf war. It's called cation competition at the plant's roots.
Cation competition.
Yeah. Roots absorb nutrients from the soil in the form of positively charged ions, which are called cations. Magnesium and potassium are both cations, and the plant absolutely needs both to survive.
Okay, so the root basically has a finite number of biological parking spots for these incoming nutrients.
That is a perfect way to visualize it. And when a blast zone is saturated with 40 grams per kilogram of explosive magnesium dust, it completely floods the parking lot.
So the potassium can't get in.
Exactly. The magnesium physically crowds out the potassium. The roots are blocked from absorbing it, and potassium is critical for regulating water and synthesizing proteins.
That's brutal.
And it gets worse. The sheer volume of magnesium alters the physical structure of the soil. It causes the dirt to compact and disperse colloidally.
Meaning what, exactly?
It traps whatever trace amounts of potassium remain inside hardened clumps of soil, so it's completely out of the plant's reach.
So the plant is basically dying of thirst for potassium while drowning in magnesium.
Exactly. And the internal damage to the plant is even more insidious, because this massive chemical imbalance fundamentally scrambles the plant's hormonal signaling.
Like its internal operating system.
Right. Plants rely on specific hormones, like abscisic acid and gibberellins, to communicate with their own cells. These hormones tell the plant when to germinate a seed, when to grow deeper roots, when to flower.
And the magnesium messes with that.
The heavy metal toxicity acts like a biological computer virus inside that operating system. It blocks the hormonal signals. So the seed in the ground never gets the chemical message to sprout.
Oh, man.
Or if it does manage to sprout, the roots never get the signal to grow deep enough to find water. So overall biomass drops drastically, and the land can just be rendered barren for decades.
But some plants do survive, right? They're stunted, they're struggling, but they live. And here's where it gets really interesting. Because those surviving plants become the vehicle for biomagnification, we're moving from the soil directly into the local wildlife.
That's right. Those surviving pasture grasses and weeds, they act like biological sponges. They pull the explosive compounds directly out of the poisoned soil.
Just sucking it right up.
Exactly. Studies clearly show that energetic materials like TNT, RDX, and HMX are readily absorbed into plant tissue. And because magnesium shares very similar uptake pathways, the heavy metallic residues from the blast are pulled right up into the leaves and stems.
So it's like a sponge left in a dirty sink. It looks perfectly green and healthy on the outside, like a normal field of grass. but inside, its cellular structure is just saturated with weaponized metal residue.
Yep.
And then, a herd of grazing cattle or wild deer wanders into that field for breakfast.
And the transfer is initiated. These grazing animals consume huge quantities of this contaminated vegetation every single day.
Yeah.
And they wash it down with water from the local streams, which, as we discussed, are catching all that toxic surface runoff.
Right, the 20 milligrams per liter limit we talked about.
Exactly. And we see this massive impact in aquatic ecosystems, too. The runoff reaches lakes and wetlands, aggressively spiking the magnesium levels for fish, freshwater mussels, aquatic invertebrates. It creates intense physiological stress across the entire aquatic food web.
So a cow grazing near a military testing range or a fish swimming in a nearby river is basically acting as a living biofilter, just trapping all that environmental magnesium inside its body over years of eating and drinking. What happens to the animal under that kind of continuous strain?
The animal develops massive, what we call body burdens.
Yeah.
They're ingesting heavy metals at a rate far exceeding what their kidneys can filter out. In cattle drinking magnesium-heavy hard water near these sites, we see severe cases of urolithiasis.
Which is kidney and urinary tract stones, right?
Yeah, massive painful stones that can be fatal. And if we look at smaller animals like cats or dogs exposed to excess magnesium, their entire metabolic systems begin to collapse.
Really? Just
Yeah.
from the environmental exposure?
Yeah, they develop severe lipid and endocrine disorders. In dogs, severe toxicity triggers cascading symptoms when the ionized magnesium in their blood serum crosses 4 milligrams per deciliter. Normal is below 2.5. Their bodies simply cannot process the heavy metal load.
Which brings us to the final inevitable stop on the food chain, the human body. So what does this all mean for you and me? The people living near these training grounds, the farmers in recovering conflict zones. They're drinking the well water, harvesting the crops, eating the meat and dairy.
And this is the crux of the public health alarm this paper is sounding. As you noted at the very beginning, humans need magnesium. We store about 53% of it in our bones and 27% in our muscle tissue.
Only a tiny bit in our blood, right?
Right, barely 1% circulates in our blood serum. Under normal dietary conditions, like if you eat a lot of spinach or almonds, your kidneys easily flush the excess. A condition called hypermagnesemia, which is toxic levels of magnesium in the blood, is incredibly rare. You usually only see it in hospitals when a patient has severe kidney failure.
But if a local population is unknowingly consuming a diet where every single element, the water they boil, the bread they bake, the beef they eat, is secretly loaded with explosive residue, they're overwhelming those natural kidney defenses.
Exactly. The continuous intake volume bypasses our biological limits entirely. What's fascinating here is the mechanism of how this toxicity actually attacks the human body. It's a terrifying two-pronged assault on the nervous system and the muscular system.
Okay, so break that down for me. If my brain is trying to tell my hand to move, where exactly is the excess magnesium interfering with that process?
Well, first, the excess magnesium acts as a severe central nervous system depressant. It physically blocks the release of a crucial neurotransmitter called acetylcholine at the nerve endings.
Acetylcholine.
Yeah, it's the messenger that carries the command from the nerve to the muscle.
So the magnesium is literally cutting the phone line between the brain and the body.
That's exactly what it's doing. And the second prong of the assault attacks the muscle itself. For a human muscle to physically contract, it requires a rapid influx of calcium. Magnesium competitively antagonizes that calcium. It jams the calcium channels, blocking the flux. So even if a rogue nerve signal somehow got through that cut phone line, the muscle is biochemically locked. It physically cannot contract.
So the brain is screaming at the body to move, the phone lines are cut, and the muscles are unplugged anyway.
Yeah, it's total paralysis.
And this isn't a sudden, immediate drop-off, right? There's a very dark, gradual escalation as the metal builds up in the blood over time.
Right. Clinicians track this creeping escalation by measuring blood serum levels in milliequivalents per liter, or NEQ per liter. When a healthy person's magnesium levels double from their normal baseline to around 5 or 10 milliQ per liter, the symptoms are deceptively mild. They'll experience nausea, vomiting, diarrhea.
Which, if you're living in a recovering conflict zone or near a mining town, you're going to assume that's just a local water bug or bad food. You would never suspect the soil itself is systematically poisoning you.
Right, you wouldn't. But as they keep eating and drinking the local harvest, the serum levels cross 10 milliQ per liter. This is when the nervous system depression really takes hold. The patient's deep tendon reflexes disappear.
Wow.
They experience profound muscle weakness. They're physically unable to stand or support their own body weight.
And if they don't get immediate diagnosis and treatment, like with fluid therapy and calcium antidotes,
When the serum levels hit 15 millicu per liter, that muscle paralysis reaches the diaphragm. The patient loses the muscular ability to expand their lungs and breathe.
oh my God.
And past 20 millicu per liter, the electrical conduction of the heart is completely jammed. The heart muscle cannot contract. It results in cardiac arrest.
That is absolutely staggering. And this is just from eating the lingering ghost of an explosion. We have to talk about the people who are actually present when these detonations happen, the soldiers training on the range, the miners setting the charges. Because eating the residue decades later is one thing, but inhaling the direct fallout has to be brutal.
The inhalation risk is severe and immediate. During a detonation, breathing in the burning magnesium oxide fumes triggers a condition called metal fume fever.
Metal fume fever.
Yeah, the tiny particles of vaporized oxide are incredibly jagged and reactive. When inhaled, they physically irritate and inflame the delicate mucous membranes of the upper respiratory tract and the alveoli deep inside the lungs.
The body's immune system must just go into absolute overdrive trying to fight off microscopic metal shards.
It does. And the tricky part is the delay. A miner or a soldier might breathe the fumes, cough a bit, and feel totally fine.
Really?
Yeah, but 4 to 12 hours later, a massive immune response hits them. They spike a high fever, get severe chills, and intense muscle pain that can incapacitate them for 2 days.
Wow.
Add in welder's flash, where the intense white flame of burning magnesium physically burns the retinas of anyone looking at the blast, and the immediate hazard is just as severe as a long-term food chain risk.
So we have a weaponized metal that eviscerates the immediate blast zone, poisons the soil, hijacks the cellular signaling of the plants, slowly breaks down the animals that graze there, and eventually paralyzes the humans who rely on that land to survive. The scale of the problem feels almost insurmountable, but the authors of the review do offer some biological countermeasures, right? Like, we aren't entirely defenseless here.
No, mitigation is absolutely possible, especially in controlled, predictable areas like civilian mining sites or established military testing ranges. One of the most promising strategies discussed is phytoremediation.
Using plants as a biological cleanup crew. But wait, we just established that the magnesium floods the soil, poisons the plants, and stunts their growth. How does phytoremediation actually work if the dirt is toxic?
Well, scientists identify and plant specific hyperaccumulator species. These are plants that have naturally evolved unique cellular defense mechanisms.
Well, I see.
These specific plants secrete organic acids from their roots that safely bind to the heavy metals in the dirt. It neutralizes the toxicity locally, which allows the plant to pull the excess magnesium out of the soil and store it in its leaves without dying.
That's incredible.
It is. You grow them, let them absorb the metal over a season, and then carefully harvest and safely dispose of the plants. It slowly pulls the poison out of the ecosystem year by year.
And I imagine if you combine that with engineering solutions like massive air purifying capture towers near test ranges and strict continuous monitoring of local water aquifers, we might actually be able to clean up these diagnostic blind spots.
Exactly. It requires a massive shift in how we prioritize and fund environmental monitoring, but the biological and engineering tools are out there if society chooses to deploy them.
And that leaves us with something really important to think about. We've spent this entire deep dive looking at magnesium, a naturally occurring, essential nutrient that we weaponize by pushing it to physical extremes. But military and industrial science does not stand still.
No, it definitely doesn't.
Researchers are currently developing next-generation explosives using entirely synthetic, highly engineered nanomaterials and artificial polymers that have never existed in nature. If the Earth's ecosystem struggles this much to process a natural element like magnesium when it's introduced violently, what happens when we start dusting the globe with complex synthetic metals? Will the soil ever be able to adapt and cycle them out? Or are we permanently altering the chemical makeup of the Earth's crust?
That is a very sobering question about the invisible, potentially permanent legacy we're leaving behind.
It really is. Thanks for joining us on this deep dive. Stay curious.